welcome, young scientists, to today's Explainer. I'm Professor Rashmika, and I am absolutely thrilled to have you here in our virtual lab today. We're going to be tackling a really big question just by looking at a totally ordinary, everyday occurrence. By the end of our time together, you'll literally have the tools to understand the grand mechanics of the solar system right from your own living room.
Okay, so here is our lab protocol for today's Explainer. We'll be looking at 1. The moving shadow mystery, 2. The merry-go-round analogy, 3. Spinning like a top, 4. Our lab setup with a globe and torch, and finally, 5. The day and night cycle.
Let's jump straight into Section 1, the moving shadow mystery.
Every good scientific discovery starts with looking closely at the world around us. When I was your age, walking home from school every day, I started noticing something kind of strange about the coconut trees lining the path. I realized their shadows were incredibly long in the morning when I walked to school, but those exact same shadows were way shorter in the afternoon on my way back. At first, my young mind just thought, well, the shadows are changing because the sun is physically moving across the sky. I mean, it made perfect sense to my eyes.
But then I remembered something super important. I had been reading this chapter called Beyond Earth in my grade 6 science textbook, and I learned that the Earth actually moved around the sun. Now that left me with a massive puzzle. If the Earth is moving around the sun, why does it look like the sun is the one moving over my house? Does the sun move in the sky, or does the Earth move? Well, that is the exact mystery we are going to solve in our lab today.
Moving right along to Section 2, the merry-go-round analogy.
Sometimes the absolute best way to understand the cosmos is just to look at a playground. Have you ever enjoyed riding a merry-go-round at a park or at school? Let's take our minds back to that feeling. You sit on the edge, a friend gives it a massive push, and suddenly you're spinning in a circle. But pay close attention to what your eyes actually see while you're on it. Do you notice how the trees, the playground benches, and the buildings around you seem to be flying past your face? They look like they're moving really fast, even though you know for a fact they're planted firmly in the ground.
Now let's take that playground observation and map it perfectly onto our planet. When we view the sky from Earth, the sun appears to rise in the east, move all the way across the sky, and set in the west. But just like on that merry-go-round, the sun only appears to be moving because we're viewing it from an Earth that is turning around itself. You and I are literally on a giant cosmic merry-go-round right now.
Which brings us to Section 3, spinning like a top.
How exactly does this giant merry-go-round spin? Think of objects you know that turn around themselves. A spinning ceiling fan, a basketball spinning on a player's finger, or a colorful spinning top. Just as a top spins around its central spindle, the Earth spins, or rotates, on its own invisible axis out in the vast darkness of space.
Let's look at the hard facts of this rotation. The Earth's axis of rotation is an imaginary line passing straight down through its geographic North Pole and out through the South Pole. Now, direction is absolutely key here. If you were floating in space and looked down at the Earth from directly above the North Pole, you'd see our planet spinning in an anti-clockwise direction, meaning it rotates from the west toward the east. And here's a mind-blowing fact for you. Right at the equator, you're spinning at over 1,000 miles per hour right now. Crazy, right? This incredibly rapid west-to-east spin is precisely why the sun appears to do the exact opposite and travel from east to west across our sky.
And here is the magic number. It takes time for a giant planet to spin completely around. That exact turning motion, one full rotation on its axis, takes about 24 hours. Because of this beautifully consistent spin, we are given the exact length of a single day on Earth.
All right, Section 4, lab setup with a globe and torch.
Now for the fun part. It's time to test our hypothesis with a hands-on home experiment. Here are your lab instructions, and I highly encourage you to try this yourself later. First, you need to grab a globe from your desk or classroom. This is going to represent our Earth. Next, find a bright torch or flashlight. This will act as our stationary sun. Now, to make the results really pop, go into a relatively dark room. Place the globe on a table and shine the light from your torch onto it from about 1.5 meters away. The absolute golden rule here, you have to keep the torch completely still.
As you shine the light steadily from the side, I want you to reach out and slowly spin the globe anti-clockwise, exactly like we learnt the real Earth does. Watch what happens to the surface of the map as it turns. Keep your eyes on one specific country, like India, and watch how it moves into the bright beam of the torchlight, and then slowly rotates right out of the light and into the shadows on the back of the globe.
And that leaves us to Section 5, the day and night cycle.
This is our final conclusion, where the mystery of this changing shadows is completely solved. Notice how the sunlight interacts with the Earth here. Just like in your home experiment, the torch light travels in straight lines and hits the globe. But because the Earth is a sphere, only half of the globe receives the light from the torch at any given time, making it daytime for the countries on that half. Meanwhile, the other half of the sphere is blocked from the light, staying in the dark and experiencing night. As the Earth rotates, places are constantly transitioning between that light and that darkness.
So the crucial takeaway is this: my childhood mystery is solved. Those coconut tree shadows I saw changing length on my way to school didn't happen because the sun was driving across the sky. They changed because the Earth itself was rotating on its axis, carrying me, the school, and those coconut trees along with it. As we rotated through that 24-hour cycle, our angle to the stationary sun kept changing, which smoothly stretched and shrank the shadows on the ground.
You followed the protocol perfectly today, and you are all official junior scientists in my book. So I want to leave you with this final thought and a little challenge. When you walk outside and observe your very own shadow tomorrow morning, just pause for a second. Instead of looking up and thinking the sun is moving, can you close your eyes and actually feel the massive Earth spinning you, the trees, and your shadow ever so smoothly toward the afternoon? Keep observing, keep questioning, and I will see you in the lab next time.